Just give others 2 minutes, then we can start. Okay. Thank you all. Thanks for joining the call. Let's start today's class. Okay. I started the meeting recording. Okay. Then let me start the screen sharing as well. Yeah. Hope you guys are able to see my screen. Hmm? Okay. Did someone dropped?
Yes, sir.
Yeah. Yeah. Start. Yeah. Okay. Let's start. Today we're going to start with Yarn. Okay. So Apache Hadoop Yarn. So yesterday and day before yesterday we covered these topics, right? This HDFS and the MapReduce. HDFS is for Hadoop storage, right? Hadoop storage component of Hadoop, and MapReduce is processing component of Hadoop, right? But as we all know, we are working inside a cluster, right? Inside a cluster. Inside the cluster, there are many nodes working together, machines working together, right? So who will manage all those resources? Like, let's say you came and submit some application to the network, okay, to the cluster. What happens? They need to send some nodes to you, some machines to you, so that you can start working on those things. But in the reality, right, think of in this way, like in production environment. Okay, so what happens in production environment? There will be many machines working together, right? And also there will be many teams or many people working for an like submitting their jobs, right? So while they are submitting their jobs, right, each job, let's say there could be jobs that are memory intensive, or there could be jobs that are very light jobs, right? For memory intensive jobs, it need more missions, right, to complete the task ASAP. But for the light jobs, right, they do not have much impact on the cluster. They need small resources. Just 2 or 3 missions are fine to complete their task, right? But in the production, right, there should be some governance should be happen, so that someone will decide, okay, to whom I need to assign, what are the resources I need to assign. Let's say someone will come and ask, even though they do not need five nodes, 5 missions to work with the task I gave them, but they will still ask the 5 nodes, right? Then there should be someone who needs to decide whether this job really needs 5 nodes or not, right? Someone needs to be there, and this yarn is the one that will do that governance for you. Governance in the sense, some monitoring, some class leader, some cluster leader, some mission leader, you can say. So it will tell you, okay, if let's say in future you someone of you go and submit a job to him, okay, job to this cluster, the yarn will come interfere and say, okay, how many nodes you need, how many nodes I have, because in the cluster always there will be some job will come and run, right? Some map reduce program will come and run, right? Then the data will move on network. There will be many things that happening in the production cluster, so someone needs to monitor those things. Then yarn is the one that will do this monitoring and all. Okay. Let's see. What is Apache Hadoop Yarn? Yarn full form is at yet another resource negotiator. Okay. So is a resource management layer in Hadoop. As you already know, resource management component in Hadoop. Okay. Yarn comes into the picture with the introduction of Hadoop 2.x. Okay. Before first there is Hadoop 1.x. Okay. For that there is no Yarn, but Yarn came into picture in 2.x. Okay. So from then this Yarn is helping the jobs to be get scheduled. Okay, it allows various data processing engines such as interactive processing, graph processing, and batch and stream processing to run process data stored in HDFS. See, if you see, this is what we wanted. We are seeing from the day one, right? So this is Hadoop HDFS. If you think this is an Hadoop environment, this is Hadoop distributed file system HDFS. This is the yarn, and this is the processing, because here you saw map reduce, right? Map reduce. You can see this Spark as well, right? So you only know this MapReduce and Spark, but these are the other processing frameworks. Okay, so this is for very fast processing. This is HBase, this is Storm. You will get to know all these things in future. But if you can remember this, this is the MapReduce, and this is the additional functionalities we mentioned in the previous. If you see, yeah, if you see here, this is the MapReduce, right? MapReduce. Here there is MapReduce and HTML, and there is no yarn here. Yarn was introduced here in 2.7. I mean in 2.x. Okay, and Spark and Storm, etc. Data processing. This is also data processing framework. MapReduce is also data processing framework, but MapReduce has some own limitation. That's why they created different companies has created different processing frameworks. Okay, Spark and Hadoop. That's how Spark came into the picture. Okay, that's small introduction about yarn. Let's see what are the components of Hadoop yarn. Okay, so in yarn, the client means who submits the job. Okay, who submits the job, and resource manager and node manager and application manager, master and container. Okay, let's see what is resource manager. We already know this, right? HDFS works in master slave architecture. Right? Master slave architecture means there will be one master that will be keep track name node and data node, right? So the name node will keep track of all the data nodes and all the data that is stored inside the data nodes, right? Similarly, this resource manager, right? It will keep track of all the nodes. Okay, but how it will keep track of all these nodes? For this resource manager, right? Think resource manager as a leader node, as a class teacher, let's say class teacher. Okay, then this node manager, right? Let's say in class you have some let's say 10 benches. Okay, that 10 bench, out of each for every bench, right, there is a one person who will be representing that bench. Okay, think in that way. So then this bench, right, if you, someone of you is not studying in that bench, then this uh, okay, let's do it this way. So let's think this as a principal. Okay, principal, and this is a class teacher. Node manager is a class teacher. Okay, and what happens? Principal wanted to know progress of each class, and what happens? This teacher, right? Node manager is a teacher. Okay, teacher will keep updating this principal that okay, in my class these are the exams we conducted, these are the lessons something. So whatever happens in the class, it will be posted to the resource manager. Okay, simple. This is a principal, school principal, and this is a class teacher. So what class teacher will do, whatever happens in this class, right, it will go and update to this principal. Okay, similarly, this whatever happens in this node in mission, right, let's say in my laptop, this is my laptop. Okay, in my laptop, if something happens, I mean whatever it may be, so if anything happens in my laptop, it will be posted to my resource manager. I mean node, I wanted to say. Okay, node. So that's what this is a master and this is a slave. Okay, you can think how this is in our working cluster. Think of a cluster. Okay, let me see. Let me draw some picture for you. Draw. See, think this as a where is this cluster? Yeah, you saw here, right? These are the data one, data nodes. These are the data blocks. I mentioned to you, right? In it's not like this. Let me put here. So this is the resource manager. Okay, resource manager RM. Okay, I mentioned it to you, right? For every laptop there will be CPU cores, right? CPU cores. As per that, you already know this. How many CPU cores in our like in my laptop there are four CPU cores. That means it can do four parallel executions. So similarly, so in this cluster, let's think this as a cluster. Okay, so cluster there could be many nodes. Okay, many nodes. This is a cluster. Okay, there could be many nodes. Okay, there could be many nodes. This is a cluster. Okay, and think this is a cluster. Okay, cluster. You have many nodes that are working together in a cluster. Okay, so in this node, right, you have a RM. In this node, you have node manager. Okay, in this you have data node randomly. So that it doesn't mean that resource manager should stay in separate node, node manager should stay in separate node, not like that. It can be there in any of the things. Now all this, right, other nodes should be DN, data nodes. Okay, so that means this is a data node. Okay, this is a data node, data node, data node. Okay, this can also be data node. So data nodes can be there. Okay, similar this resource manager, right? Resource manager is a master. Okay, that means it will have some node manager. Node manager means NMR, let's say NMR, node manager. This can be there in every. This should be there in. Copy this. This is a node manager. That means someone needs to keep posted this node manager, that a resource manager, that okay, this node, let's say if something is happens in this node, right, this node, then this node manager will keep posting, will keep this resource manager posted, right? Okay, so this is NMR, node manager. Okay, this is data node. Data node means you can go and store. This is data node is open. Like let's say if any client comes and submit the request, this is the name node, right? Name node will take that. Name node will take that. Okay. Um, name node will take that. Okay, name node will take that request. Okay, then it will give the data nodes it has, right? It has data node everywhere in this cluster. All these group of resources, group of things will work together to form a cluster. Okay, it doesn't mean that MapReduce is a separate cluster and is a separate cluster. No, all this group of resources will work together to form a cluster, and in that cluster you have a name node, you have a data node, you have a resource manager, you have a node manager. So why this node manager? Maybe you already got to know, right? Whatever happens in this node, right, that should be posted to the resource manager, right? Now resource manager, if you think this is the same cluster, okay, if you think this resource manager in your perspective, this is the master node, master resource manager. There is no master slave, it's a master slave architecture, but we call this master as a resource manager, and everything is a node manager. Okay, and if you consider this as a HDFS, this name node is the master and data node is the slave. You already know what is the master and slave, right? So master will say give some instructions, and the slaves will follow those instructions. That's how it works, right? Now, um, now similarly, this is the resource manager, okay, and this is the node manager. Perfect. Whatever happens in this node, that will be posted to the resource manager. Perfect. Okay. Now container and application master. Let's see application master. Application master means, so whenever someone comes and submits a job, okay, let's say this client came and submitted this job, right? Then this resource manager will launch an application master. Why? Because he submitted, this client submitted some job, right? So that job, to track that job, is that job completed, is there any issue in that job, what was the job, all these details, there should be someone that needs to keep track of. That's what this application master will do. Application master, you already know. Let's say whenever you submit a job, application master will get launched. Okay, and similarly for client, right, this is client one, let's say client two. So for client one, that means he submitted, let's say, job A. Okay, job A. um what is this pen? This is job one. Okay, job one, and this is job two. See, now as I mentioned, someone needs to create this job, right? When job one is started, then application master one is started. This is for job one. Okay, job one. Okay, and whenever job two is launched, right? Job one is submitted to the resource manager, then job two is got created. Okay, so this is job two. I mean application master for job two. Okay, now let's say this job one is to specify, let's say, count number of votes in a PDF. Okay, and the other job is to count number of words in a book. Okay, so if you think in real time, right, the book has many number of words, right, compared to this PDF, right? Then this job two is a heavy job. You know, right? To job one is to count number of words in a PDF. Let's say this PDF, this is very less. Let's say 20, 18 pages only. But if you give this job to is a book number of, it's a PDF, right? The book is also in PDF. The book size will be, there will be many pages, right? Let's say for that book it will have, let's say, 200 pages or something. So that is a huge task, right? That means, now tell me, out of this job one and job two, which job needs more resources? Which job needs less resources? You just let me know. Hello, hello. Which job? Job one or job two? Which needs more resources? Job one is for just calculate number of words in a 10, 20 pages PDF. Job two is to calculate number of words in a 200 pages PDF. Hello?
It
Yeah.
job 2 needs more, sir. Job
Job
1 needs.
two needs. Okay. Okay. Now job two needs more resources. Now let's say I have 10 resources. Okay, 10 resources. Now I will give this job one. Okay, this job one, out of 10 resources, I will give 6 by 10. Okay. Now for job 2, I will give 4 by 10. Okay, 4 by 10. So is it fair? Do you think is it fair? Because this job 2 needs obviously more resources, but I gave only 4 resources for this job 2. But job 1 has many resources. Do you think this is fair?
No.
No fair, because job 2 supposed to be receive more resources so that it can complete fastly. But job 1 got more resources, which is definitely unfair. This is unoptimal way, right? This is not the correct way. Then this is what this resource manager will do. What resources manager will do is it will, before allocating, this will create an application master, right? This application master, right? It needs to provide this resource manager how many nodes you need, how many nodes you need for to process your job. Then this resource manager, right, it will negotiate. Let's say this application master will come and ask, I need all 10 missions. Then this resource manager will say, why you need all 10 missions? Because there are many other jobs, there could be many other jobs, I need to process them. Somehow this resource manager will try to negotiate with this application master, but application master needs to convince this resource manager. Okay, then resource manager is convinced, it will provide all the resource, all the 10 missions. But if it's not convinced, it won't give you, it will give you only 1 or 2 missions. Okay, based on its convenience. Then this application master, once it got application master got the approval, then it will go to this, it will take, okay, application, you got the approval, then let's wherever you want mission rights, these are the 3 missions. Let's say this application master will go and will be launched in one of the node. Fine. Now this application master checked with the resource manager how many resources it want. The application master say, let's say I want 6 resources. Then this application master or resource manager will grant those 6 resources. Similar to this data node, right? Let's say you have a one block, it will give you 3 data node addresses, right? If you have 2 blocks, then it will give you 6 data node addresses. Similarly, this application master will get some IP addresses. Then this application master will go to those IP node manager, and it will instruct that node manager that, hey, I just had a discussion with resource manager and I need these many resources, and resource manager already approved those many resources. Okay, let's say this application master 6 resources, it will go to say, hey node manager, I need 6 resources, 6 missions to work for to run my job. I had a discussion with resource manager and resource manager has approved it. Then this node manager will check with this node resource manager. If it's approved, then this node manager can launch a container. What is a container? Okay, what is a container? Container means, as I mentioned earlier, every laptop will have. Let's go and see some example. So far clear, right? Any doubt so far? This is my mission. Okay, in my mission, um, let's say this is CPU core 1. I mentioned it to you, right? CPU core 2. Let me show you again that example. This is my mission. Okay, in my mission, there are these CPU cores. Yeah, yeah. If you see here, this is my CPU, this is my memory, this is my disk, this is Wi-Fi, this is GPU. Ignore all these things. Just think about this CPU, memory, and disk. What is memory here? Memory is RAM. Disk is ROM, SSD. If you see here, SSD. Right? CPU is CPU, like number of CPU cores I have. If you see here, I have 4 CPU cores. Right? You can see my screen, right? Yes or no?
Yes, sir.
Yes, yes.
Okay. You see how many CPU cores you can see here? 4. That means this 4 CPU cores, right? Now let's go to here, 4 CPU cores. That means as we already discussed, how many parallel tasks I can run based on this CPU cores. Just let me know how many parallel tasks I can run based on this CPU cores. We already discussed in the previous classes.
4.
4, right? Okay. Now there are the 4 CPU cores. CPU core 1. Okay. That means you can run this CPU cores. Okay. Similarly, so this is a mission. This is a CPU core, and if you see here, what is the memory here? Memory is 7.9 GB RAM. Okay, RAM. And disk is, for your information, you cannot see it here, but disk size is like 512 MB. Okay, 512 GB. Okay. Now what happens here is this. Let's say, where is this? Okay. Now I need a container, right? In this container, let's say you wanted to process one block. one block. Okay, that means one block of data, small amount of data. So for that block I will assign this CPU core. Okay, this CPU core, this CPU core, this CPU core I will assign for that one block of data. And this, out of this 7.9 GB, right, RAM, I will give 2 GB of RAM. 2 GB of RAM. Okay, now I still have let's say 8 GB of RAM, right? I have 4 CPU cores. That means 4 CPU cores. Okay, 4 CPU, and I have 8 GB of RAM. Okay, so these are the resources I have. Now this, I need one task, right? When application master check with this thing, it will tell that application master how much amount of data I need to process. Application master will tell this resource manager that, okay, I need to, okay, I need these many node. Okay, these many resources. Then accordingly, based on those resources, it will launch this application. Now this 2 GB RAM and this node, right? This CPU core, right? This is a CPU core, right? CPU core. This is the CPU core. One CPU core. The CPU core will be given to this application master one. Okay. Now, if application master needs one more CPU core, then this will be given to that application master two. Okay. Application master two. Let's say if any one more another job comes, right, then this will be given to this application master two. Okay. That means this node and this 2 GB RAM will be assigned to application master one. Okay. Application master one. AM means application master one. Okay, this CPU core and this 2 GB RAM will be given to application master one, and this, right, this will be given to application master if needed. If needed, okay. I have 4 CPU cores in my mission. If someone comes and this application master will go and check with the resource manager. Hey, resource manager, I want these many nodes, these many CPU cores. Then this CPU core, right? This CPU core and this 2 GB of RAM is a container to my laptop. Okay, then this container will be given to this application master one. Similarly, you will have so many missions, right? In each mission, if you see here, you have three missions here, three missions, right? Three missions, then one container is created here, one is created here, two containers are created here. See, right? That's how the containers are created. Okay, so far clear? Any doubts? Any
No,
doubts? No.
no,
No.
Fine. Okay. Okay. Can someone tell me what you understand? Just simple way. This is a simple context I just gave you. I will dive into this technical concept now. Just tell me what happening here. As a and you can consider as a yeah. What is resource manager? What is node manager? Container application. That's it. Simple words. Please, someone let me know what is this. Hello.
sir, resource manager
Hmm.
is responsible for allocating and the resources.
Exactly. Exactly. Yeah. What is
Node
node?
manage
Hmm.
to manage the resources, sir.
Manage the nodes. You can say.
Resources, nodes.
Resources. Manage the resource. Perfect. Container.
It will execute, sir.
To not execute, it is a small part of this node manager. Resources, container is a resources. Let's say you just saw this example, right? Here you have this, if you see, this is your entire mission. In that entire mission, these are the resources you have, for 8 GB of RAM and 4 CPU cores you have, right? If you see here in my laptop, there are 4 CPU cores, and this memory is 8 GB, right? And this is SSD. Now this is divided into 4. Okay, so based on, let's see, if I have 8 here, 8 CPU cores, that means it will divide into 8 parts. Here I have only 4. That means I need to divide my resources, my CPU, memory, and disk into 4 parts. If I have 8, I will divide into 8 parts. As I have only 4 parts, these 4 CPU cores will go into one CPU core, one CPU core, one CPU core. And memory of 8 GB of RAM will go into 2 GB of RAM, 2 GB of RAM, 2 GB of RAM, 2 GB of RAM. This SSD, right, I gave 512 MB, 512 of GB. Let's go with 80 GB only. That means 10 GB of data to CPU core 1. Okay, you can understand, right? Like if I go here, this is will be 1. Okay, this will be one. Okay, in the same laptop, in my same laptop, these are the four nodes, four separate containers I can create. This is in the same laptop. See, now this is have 2 GB of RAM. Okay, 2 GB of RAM, 2 GB of RAM, one CPU core, and 10 GB of HDD hard disk. Okay, now this is a container. Similarly, similarly this one, right? Similarly here you have again you have it here, again you have it here, right? This is my, if you understand how many GB of RAM I have here in total, you can
Eight.
speak up. 8. Okay. How many CPU cores I have here? 4 CPU cores.
Four.
How many hard disk I have? 40. I mean,
40.
for now 40, it's 512 GB. 512 by 4, I will give it here accordingly. Okay, it's same. Now this is a container 1. Okay, this is container 1. Okay, this is container 2, container 3, container 4. Right. Now if application master go and request, right, application master will go and request resource manager. Right. Now what is application master? Just let me know. What application master will do?
Sir, it negotiates the resource.
Yes, exactly. Resource. Now it got the approval from the resource manager, right? Then resource manager will say that, okay, you can go and have your container in so and so manager, right? Then the application master will come to this node manager and tell them, okay, I got the approval, just give me a container. It will give you the container. Then the application master, this resource manager will give you definitely different node managers, multiple node managers, right? It needs to go to every node manager and launch a container there. Okay. Similarly, launch a container means like this: container 1, container 2. Let's say in this node manager, this application master gave approval for two containers. That means it can launch two containers here. Okay, now it will launch the containers. Okay, the container means the like the CPU, RAM and ROM of that machine. Okay, small part of that entire storage of that machine. Okay, clear, right? A container, application master, node manager and resource manager.
Yes,
Okay.
sir.
Okay, so other than Arun, what else? What about others? Are you clear, right?
Yes,
Karthik, Deepti, Veda, Anusha.
Yes, sir.
Okay, cool.
yes,
Any
Yes, sir.
doubts, just let me know. I just provided the multiple documents, right? You can just go let's see. Now let's start this components of yarn. Okay, then that's it. It'll be good. Okay, what is resource manager? As you already know, resource manager is the master daemon means there, like in programming or languages, we don't see the scripts running, but in the background, most of the scripts will get run. So that's master daemon, master process, whatever. So master, okay, master of yarn, responsible for managing several other applications along with global assignment of resources such as CPU and memory. Like right, resource manager will allocate the resources. And it is used for job scheduling. Resource manager has two components. Okay, job scheduling, because I mentioned to you, right? So here, let's say there are two clients coming and separating submitting the jobs. Let's say this job 2 got submitted first. That means it's a huge task, right? Then that's kept running on this mission. Okay, this entire clusters. Okay, so it is not free. Now this job 1 came, right? And job 3 came. There are 10 jobs came at the same time. Think how this resource manager will handle, right? It needs to schedule those jobs. Needs to schedule those jobs based on the first in first out something. Like, okay, you know the queue, right? So if you go in first in the line, then your job will get submitted first. It will run first. If you're in the last in the queue, then your job will get run last in the queue. Okay, last. Similarly, this who will take care of that? Who will take care of that schedule? The scheduler will take care. Resource manager has two components: scheduler and application manager. Okay, application manager. The scheduler's task is to distribute resources to the running application. It only deals with the scheduling of tasks, and hence it performs no tracking, no monitoring of application. So whenever you submit an application, write this to server, resource managers will take this request. It will launch an application master. Now application master needs to, let's say you went to some place, let's say some bank. Okay, so you went for some loan application. So the bank will assign some person to you, right? He needs to talk with you along, and he needs to talk with their authorities as well, SBA manager or whoever may be. Right? He is the mediator, let's say, this application master. Now application master needs to talk with resource manager, tell him, okay, how many nodes it needs, how many containers it needs. Then this resource manager will provide them. Right? Now this once this is done, then your job will get started in this container, right? These nodes containers will work to process your data, right? then then once that is started, then your job will start running. For example, this container, somehow this container got failed, the task that is running in this container got failed, then who will track those things, right? Someone needs to track those. If this container got failed, the same task, right, the same task needs to be is to be launched in some other container. Okay, let's say this container or this container, some place it needs to be restarted, that task, that failed task, right? Someone needs to manage those things, right? Who will manage those things, we will see. The scheduler is someone who will schedule the this running applications. Okay, it only deals with the scheduling of task. Okay, schedule of task, and hence it performs no tracking and no monitoring of applications. Okay, it won't track, it will just schedule. It will schedule, hey, you just run it, you just go there and you just run your application, that's it. It will say that, but it will never track it. Who will track it? The application manager manages applications running in the cluster, and tasks such as starting of application master or monitoring are done by the application manager. Let's say you launched an application master. An application master is the if application master dies, then this entire job will get die. Job will get failed. If application master fail with some issue, then entire job will get stopped. If there is no representative for that job, right, then this resource manager won't let the job to run, because there is no one who is representing that job, right? So this application in resource manager, you have two components: scheduler and application manager. Scheduler will schedule a task, will give the resources, and it will ask them to start your job. You will start your job. Application master will start the application master. It will monitor that application master. Okay. Now node manager. Node manager is a slave for this yarn. Fine, you know that. Node manager too has to monitor containers resource uses along with the reporting into resource manager. You already know this container resource uses. Let's say you saw this, right? You saw this. In these containers, these two containers are occupied. Okay, these two containers are occupied. That means only two containers are left. That the resource manager cannot ask this node to the system to have four containers. Give four containers to the application master. No, it cannot give it, because out of four, already two got occupied. Only two are left. Right? That same information needs to be conveyed to the resource manager. This will be conveyed by node manager. Right? It will keep explaining. The class teacher will always keep this principle posted, right, about the what happening in the class. Right? Similarly, and the health of the node of which yarn is running is tracked by the node manager, right? Health of the node, definitely. How the health of this monitor, CPU, RAM, all these things. Take care of each node in the cluster while managing the workflow along with the user jobs as on a particular node. Okay, so the tasks, health of the cluster, and all these things will be taken care by this node manager. It keeps data in the resource manager updated. Like it will always keep this resource manager updated about the details happening in that single node. Node manager can also destroy or kill the container if it gets an order from the resource manager to do so. Okay, if this node manager, right, you have a node manager here, node manager, right, this is a node manager. Node manager cannot kill the task that is going here. Okay, it will never uh, kill the task that is running here, but it will kill the task if it get instruction for this resource manager. Okay, if it gets a instruction from resource manager to kill the task, then it can kill, but on its own it will never kill the task. Okay, just remember that. Okay, now let's see application master. Every job submitted to the framework is an application. Okay, every job is an application, and every application has a specific application master associated with it. Okay, now application master perform the following task. As you already know what application master will do, it coordinates the execution of the application in the cluster along with the managing the faults. Faults in the sense, in case anything fails, okay, it will go and tell the resource manager. Resource manager, you gave some container, it got failed. Just let me know where I can start my failed task, something like that. Okay, it negotiates resources with the resource manager. You already know. It works with the node manager for executing and monitoring the other component task. Okay, it will go and ask this node manager, hey node manager, I need to work with you, so to run my launch my containers, and I need to start my task there. Okay, at regular intervals, heartbeats are sent to resource managers for checking its health. Okay, in this entire cluster, right? Not only here, in entire cluster, the HDFS, whatever. This is entire cluster, right? Let's say this is a name node, right? Name node. Okay. All the data nodes, right? This is data node. This is data node. This is data node, right? These data nodes, these data nodes needs to send some signal to this name node. Otherwise, this name node will consider this data node is dead. Okay. Similarly, all the data nodes needs to send uh, all the slaves needs to send some signal to master. Otherwise, master will consider that that slave is dead. Similarly, for resource manager, right? These node managers are the slaves. Resource manager is the master. This node managers needs to send some signal to this resource manager. Okay, if no signal is sent, then this resource manager will consider that this node manager is dead. Okay, now that's what it says here. There is this regular intervals, heartbeats. Heartbeat means signals are sent. Regular interval in the sense you can consider 3 seconds. Every 3 seconds, node manager needs to send some signal to this resource manager. If no signal received, that means resource manager will consider that this node manager is dead. Okay, then it will try to spin up the same task in that node manager into separate node. Okay, for checking its health along with updating records according to its resource demands. Okay, regular intervals it needs to send. Now we will step forward with the fourth component of Apache Hadoop, container. As I already told, right, container is a set of physical resources, CPU, cores, RAM, disk on a single node. You already know what is a container. The tasks of a container listed below. It grants the right to an application to use the specific amount of resources on a specific host. This container is the one where this application master will utilize to run its task, single task. Okay, let's say you have a four task in your job. Okay, four task. That means you need four containers, right? Let's say you have four blocks. How many tasks you will have in your application? Let me know. Four blocks. Then how many tasks? Map a task, reduce the time. We
For
already four, right? Now, similarly, these four tasks, right? This four task, right? This four task needs four containers. Okay, four blocks need four tasks. Four task means four containers. Now, this container set of physical resources you already know. It grants the right to application to use specific amount of resources on a specific host, specific mission node, whatever we call it as. Okay. Yarn containers are particularly managed by container launch context, which is a container lifecycle. This is something that happens in the background. You don't need to worry about this. Yarn containers, right? The containers are particularly managed by container launch. There is one more manager who will manage this container launch and all, right? No need to worry. It will be run in the background. This record contains a map of environment variables, dependencies stored in remotely accessible storage, secret tokens, payloads, node managers. So to container, right? Container needs some permissions. In the background, this container needs some permission because the data that is stored in the HDFS, right, that cannot be accessed directly. You need to come to name node and name node will tell you to go and access where is this data, right? They need some permission. This permission will be taking care of this environment variables, dependencies, all these kind of things will get taken care. Okay. Now see, running an application through yarn. Let's see, this is the final. Okay. Now application submission. Someone needs to come and submit the application. Step one, application submission. Okay. Now once application is submitted, the RM accepts the resource manager. Okay, resource manager will accept the application, causing the creation of application master. You know, right? Whenever resource manager accepts the application, it will create an application master, right? The application master is responsible for negotiating resources from the resource manager and working with the node managers to execute and monitor the task. Right? We already saw it here. This application master, this client will come and submit the job. Resource manager will take that job one or job two, whatever maybe. He will launch the application master immediately. Application master will need to negotiate with resource manager for the resources. And once you got the permission, it needs to go to node manager and tell, hey node manager, I got the permission from the resource manager and I need a container from your four containers or whatever containers you have. Okay. Self-explanatory slide. No resource request. The AM starts by requesting resources from the resource manager. You already know that. It specifies what resources are needed, in which location, and other constraints. In which location it needs, something like that. It will ask these resources because let's say this is a data. This is a name node, right? Name node will instruct data nodes to store the data. Fine. Similarly, resource managers will instruct node managers, right? Similarly, it will instruct. Now, this resource manager will this application master will get launched here. Let's say application master get launched here. Application master got launched here. Application master will ask that, let's say it needs to process this data node. It will ask that, hey, a resource manager, I need my container here because I already have the data node here. If you can provide a container here, I can process my data here itself. Or if it's not available, then provide me somewhere here. Then I will bring this data node via network to here and process the application, process the data node. I mean data, you can call it, block of data. Data node will contains the data, right? So the data. Now this resource allocation, once resource request is done, the resources are considered in terms of resource containers, which includes specification like memory size, CPU, as you already know, RAM, disk, all these things. The scheduler is now resource allocation. Scheduler, we already saw here, right? What is scheduler? What is application master? Scheduler will his job is to distribute resources to the running application and schedule the task. Okay, it won't perform any tracking, no monitoring. Similarly, this scheduler in resource manager based on the current system load and capacity, because it will check, okay, how many resources are running, what's the available resources, available containers. Based on that, it will allocate the resources. Okay. Now, allocate resources to the application by granting the containers. Fine. The specific strategy depends on the scheduler type, like FIFO, first in, first out. Like who came first will get executed first. Who came last will get executed last. Right? Okay. Now, the container launching. Post allocation, the RM communicates the relevant node managers to launch the containers. It will ask, okay, here is a bit correction. Resource manager will directly ask those node managers to launch the containers, and node managers set up the containers environment, then start the container by execute the specified commands. Okay, now containers will get started. Now task execution. Each container then runs the task assigned by the application master. Whatever this container resource manager will tell to node manager is, he'll launch a container, fine, and report to this application master till this job is completed. Now these resource managers, right, uh, as asked by node managers, right, as asked by resource manager, they need to report to application master until that task got completed. Okay, so the task execution, each container then runs the task assigned by the application master. Okay, these are actually data processing tasks specific to the application's purpose, right? Task execution, we need to process data, whatever may be the task. Now, monitoring and fault tolerance. The application master monitors the progress of each task. Application master, if container fails, the application master requests a new container from the RM and retrace the task. As you already know, if any application got failed, any task got failed, then this application master will go and ask for the new container, launch that new container, and retrace the task, ensuring fault tolerance in the execution phase. Okay. Now, completeness and release of resources. Upon task completion, application master resources allocated to containers, freeing up resources. After all tasks are complete, application master itself is terminated and resources are also released. Fine, self-explanatory. The client then polls the RM to receive a notification to know the status of the application. Once informed of the completion, the client retrieves the result and finishes the process, because the client is waiting for this completion, right? The client, it needs to know that, okay, your application got completed successfully, right? That's a step here. Now this is the one. First, run job command. You will submit the job. Okay. Get new application ID. This, what will this resource manager? This will be received by the resource manager. Resource manager to get new application. Resource manager will take the application. Okay. Then it will, okay. Okay, you can submit the job. Then it will submit the job. The moment resource manager is launched, it will go and launch the application master. Okay. It will go and launch the application master. See, if you could see. Okay. See, this is step one, run a job. Step two, this resource manager will receive the application. Step three is the step three, copy job resources. Job resources means where is my file, all those kind of stuff. It will get copied. Okay. Now step four, it will submit the application. It will tell that I need to run my job. Resource manager will take those details. Okay. And in the meantime, this client, right, the client will collect this where the files, right, HFS, the files will be stored somewhere. You need to collect those details. It will collect those details. And now step four, right, it will submit the application. Once the application is submitted, what is the fifth step? It will start a container. It will ask this node manager to start a container. And this node manager will start, what it will start? It will start application master. Application master is the starting point of your job. Okay, once it's started, then it will go and check from the stored procedures, I mean shared file system, what's happening, I mean what was there inside this HDFS, I mean what are the data nodes I need to process, where is my data is located, fine, and how I need to process, how many containers I need, all those things, input splits, right? Number of blocks equal to number of tasks is equal to number of containers, like that it will get all the details. Then it will go to this resource manager for the resource allocation. I need these many resources. Now it will give the permission. Once it got the permission, it will go to node manager and say, hey, I got the permission, please launch a task, please launch a container to me. This container will get launched. Now this task will get started here. Okay, map task or reduce task, what are the tasks? Okay, based on that you will get started. Now this application master will keep track of all the tasks that are running inside the cluster. Based on that its completion, it will update this resource manager that okay, my application is completed, I'm terminating, please update to my client. That's it. Okay, so that's what this yarn is. So for any doubts, that's it about that yarn. So we are done with Hadoop, MapReduce, and yarn as well. I know it will be a bit difficult for you. There are many new concepts that you learned today. Okay, so I already created some documents. Okay, you can just go through these two documents, and you will understand most of the things. Okay, I will upload here. Okay, that's it. Any questions? Anything so far? Hello.
Sir, you can share this material to group, sir, WhatsApp group.
Yeah, sure. I'll share in the WhatsApp group only. Okay. Hmm.
Yes.
Yeah. So now I want everyone to tell me what happens in a cluster for in respective to yarn. Simple words. What is yarn? First thing. Okay. What is yarn? And what happens when you submit a job to the yarn? And what are the technology? Source manager, node manager, container, application master. How sequence of steps? I just wanted to hear from you. Okay. Who will start? Don't worry. Just start. I'll let you know. If anything, any issue, anything is incorrect, I will correct you. Okay. Okay. So who's gonna start that? Before starting, I will again walk you through what happens inside the cluster. Let's say I went to this resource manager, submitted my job. Now resource manager will immediately launch application master. Application master is will go to this resource manager and ask how many resources it needs. Okay. Now once resource manager give the permission, now this give the okay, then resource manager will go to the node manager and tell, hey node manager, launch a container and have that container reported to this application master. Now the application master will use this node containers to run a task. Once tasks are completed, application master will also get terminated. If any task got failed, application master will relaunch the container in some other nodes, and and it will retry the task. That's it. Simple. Now just someone repeat. Tell me what's happening in this. Yeah, simple words. This container technical on all these things, right? You need to read the document. Otherwise, you will never remember that. These are very some bit complex topics. Okay, just tell me what's happening in the high level. That's it. Yeah. Arun, Arun, you wanna go first?
Yes,
Yeah.
sir.
Yeah. Start.
The client will initiate, sir,
Okay.
and he will submit the information to the framework,
Okay.
and it will then client then it will submit to resource manager, sir.
Sub resource manager. Yeah.
Yeah, and resource manager whereby resource will be assigned and managed, sir.
Okay.
And there it has two scheduler and application manager.
Yes. Exactly.
Scheduler performs schedule based on allocated application and resource, sir.
Hmm. Yes.
And application manager it is responsible for accepting the application,
Hmm.
negotiating. Then node manager will take care of the individual nodes, sir.
Individual nodes.
Uh,
Exactly.
on the Hadoop cluster, it manages the workflow.
Hmm. Yeah.
And then the next it will pass to the application manager where single job will be submitted.
Not single task, not single job, single
Multiple
task,
tasks, sir.
multiple task. Oh, yeah, yeah.
And the application it will also negotiate the resource with it will negotiate with resource manager
Hmm.
and it will track the status, sir.
Yes.
And after application manager it will send to container
Hmm.
where it will collect all resources
Hmm.
where it will RAM and other parts will
Hmm.
exist, sir.
All the resources, CPU, RAM, and hard disk.
Yes, sir. Once
Hmm.
the process an application could be executed in container,
Hmm.
client will another contact resource manager, application manager, and will check the status, sir.
Okay.
And once the process is complete, the application manager will uh, unregister with the resource manager in the process.
Hmm. Yeah,
And
yeah. Fair enough, fair enough. Yeah, you're almost there, almost there. Just go through this document once again. Then you might get few doubts. You can just Google it and see. Otherwise, you're almost there. You're 90% there. Perfect. Yeah.
okay,
Yeah, who wanna go next? Thank you, Arun. Thank you.
thank
Who wanna go next? Deepti, Veda, Karthik, Hanusha. Who wanna go next?
Yes.
Yeah, Deepti.
Yeah, like first thing is like client submits job to resource manager.
Exactly.
Yeah, then resource manager assigns resource, like launches the application
Mission master.
inside the container.
Okay. Okay.
And application master request more containers to resource
Hmm.
manager.
Yes.
And node manager launch containers, then
Hmm.
it will execute tasks.
Exactly.
Then
Exactly. Yeah.
then status flows back to the client.
Exactly, perfectly good. In the high level, this is fine. You guys understand high level view, but in the technical point of view, right? Just what are the things that run in resource manager? What are the things that run in node manager? All these things. Just go through this document. You will get used to that. Okay, fine, fine, good.
Okay, okay. Sure.
Okay, now who's next?
Um,
Yeah, wait.
a client submits a job.
Okay.
The resource manager creates um,
Application master.
application master for
Hmm.
for that job.
Hmm.
The application master asks the resource manager for
Hmm.
like for the resources like
Resources.
CPU and
Hmm.
memory.
Hmm.
And then the these
Hmm.
resource are um, given like they're given to the containers
Hmm.
on like different
Right.
machines.
Once application master ask for this containers, right?
Mm.
Then this resource manager will instruct this node manager to to launch those
Run,
containers.
yeah.
Okay.
Okay. Then the job task run inside these containers,
Containers. Yes.
and the result is reported to
Hmm.
uh, like back to the client.
Client. Yeah. What happens if any one of the task got failed? Will it get relaunched or the entire job will get failed? One of the tasks. Let's say you have 10 tasks, 10 blocks, 10 tasks, 10 containers. One of the tasks got failed. That means one container got failed. Then what happens?
it will relaunch.
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 Relaunch. Okay, relaunch the task in one another container. I mean, it will, let's say the container failed due to some network issue or whatever, maybe any issue, it will get relaunched. Okay, fine, cool. Almost there, fine. You can just go to the document and you will get to know more details. Okay, technical way, just try to put it in technical way. Whenever some interview someone asks, this is one of the interview question, what is yarn, how it works, what happens when you submit the job. Okay, then you can just mention these steps. Fine. Now Karthik and Anusha, I think you guys left, right? Yeah.
Yes, sir. So,
Yeah.
firstly, the client actually submits an application, sir, to the
Okay.
resource manager, and
Okay.
then from there it allocates to a container where it will start the application manager.
Okay.
From that application, it will register by itself with the resource manager.
Okay.
When once it's done, the application manager negotiates the
Hmm.
containers from the resource manager.
Okay.
From then, the application manager it notifies the node, sir, manager to launch the
Hmm.
containers.
Okay.
In application, again the code is executed in the container only,
Exactly.
where
Yeah.
the client they will actually
Hmm.
contact the resource
Okay.
manager.
Hmm.
Once that is done, it will actually monitor the application, sir.
Hmm. Okay.
So then once it will be done, it will take the processing is complete with the
Hmm.
application manager.
Application manager. Yeah.
Yes, then it will unregister with the resource manager.
Resource manager. Yeah. That means now one more job can come and get executed.
Yes, sir.
Okay. Okay. Fair enough. Fair enough. You can just go to the document again. Then you will get to know more details, right? What is yarn?
Yes, sir.
How things happening? All this things. Yeah. Karthik. Karthik, you're on mute. Um. Hello, Karthik. Okay. Seems to be some issue with the Karthik side. Okay. Okay. So, any other doubts in this today's class or something? You have any doubts or anything? Because this is what Hadoop, MapReduce, and Yarn looks like. Today we are done with all those three concepts. Okay. Tomorrow, before starting new concept, I wanted to start on Spark side as well. But yeah, I need to discuss with Subhashri and then I need to start. Okay. Otherwise, we are supposed to start on AWS side. Okay. Fine. I'll let you know on what we are going to discuss on tomorrow. Dipti, you want to say something?
No, 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 sir.
Yeah. Yeah. No doubts. Then we can wind up. If any doubts, just let me know.
No, sir, no doubt.
No, sir.
No, sir.
Okay. Just go through the document again. Next time when I ask about the yarn, right, you need to come up with some technical details. What happens? Okay. And just go memorize these kind of diagrams. I mean, not exactly. This is not the proper diagram, I will say. But yeah, this is a cluster which has data node, name node. This is name node. This is application node, application master, node managers, and all. This is how typical cluster production cluster looks like. It doesn't mean that this is MapReduce cluster, this is HDFS cluster, this is Yarn cluster. No, entire cluster runs in the same place only. Okay, same nodes only. Okay. Yeah, that's it for today's class. We can connect tomorrow. Okay. Thank you. Thank you, everyone. Yeah. Bye.
Thank you, sir.
Thank you, sir.
Thank you. Bye.